Okay, lesson 1, activity 2, find the area of this trapezoid. So, maybe I didn't write down something from, I don't have the phone here. I thought this was 6 centimeters down here. Yeah, we'd have to know that. I think this is 6 centimeters. And that is, so this is another messed up drawing that they did here. Okay, let's do it here. We're going to find this area, we need to find this height here. So, well, it's not that difficult. And then I'll show you why I don't like the drawing. You can probably see that already. Because, well, here we go. We'll just do it. If this is 60 degrees, then you know cosine of 60 is half, right? Is a half. So this has to be 2 down here. So that only leaves a length of 4 left for this. So this has actually got a backward slant to it. This line here comes in. Sorry if that confuses you. You'll see it here. You know what I mean? If this is cosine of 60 equals a half, correct? Equals adjacent over hypotenuse. All right? So this length right here, if we drop this, if we call this h, then the length of HC is 2. Okay, equals 2 over 4. And what is this side over here? It's 2 square root of 3, am I correct? Because you're doing the sine of 60 equals h over 4. So h equals 4 sine and 60. Sine of 60 is square root of 3 over 2. It's one of those special triangles, right? This is a special right triangle here. So 4 square root of 3 over 2 equals 2 square root of 3. 2 square root of 3. So now, if you, from your book, if you know, if you have that, you have a lot of things memorized. So you know the area of a trapezoid is 1/2 the, let's see, let's write that a different way. You got the height times base 1 plus base 2 divided by 2. And I'll show a little extra on there. So you can just stick in the values there, no problem. Area equals 5 plus 6 times 2 square root of 3 over 2. So area equals 11 square root of 3. And if you need that in decimal form, you know, stick it in your calculator. Okay, one thing I wanted to show, like, did they show that in your book, how you get that formula? I think they do. But if I take any trapezoid, and so like I say, this trapezoid is kind of messed up because this is 2. If the whole length is 6, well, that leaves you with only 4 here. So there'd be a little right triangle here. That's 1, and this would be 4. So you'd have this 4. You'd have this little rectangle in the center, right, and a little triangle like that. Not this. But it doesn't matter. You found the area. See, even if you didn't understand that, it doesn't matter. You got base 1, 5 plus 6 times 2 square root of 3 divided by 2. Okay, now so where does they get that formula from? I'm not sure they show it. So for instance, here's this another little fiddling around with the trapezoid. If I take this midpoint and I spin this trapezoid around, I flip it around to where this top, so I've got, let's call this base 1 and this base 2. I flip it around to where I've got base 2 up here. So I spin a copy of this. So I got two of these. I spin one around, and then here's base 1 over here, and here this side is now over here. So when you do this, I did a bad drawing here again, but what I have is, what shape now do I have? What shape is this whole thing? Well, it's a parallelogram. And remember so let's write the area, the formula for the area of this parallelogram. The area of the whole parallelogram is this base times the height. So you got the height times that entire length, base 2 plus base 1, or base 1 plus base 2. And then, but I want the area of just half of it. I want the area of one of the trapezoids, so I divide by 2. So that's one way to see that where you get that formula for the area of a trapezoid. But you're great at memorizing things, but there's a nice little proof of it, a visual proof. And while we're at it, how did we get to I think they show how you get to, if you take any old triangle like this, and you spin that triangle around this, you would wind up with this side over here. You got this height. You could always take this copy and move it over here, and then you wind up with a rectangle, right? So moving around these triangles and angles, and you can see why the area of a parallelogram is the same as the area of a rectangle, and you make sure you always use the altitude for the height. You don't use one of the angled sides. Okay, well, I hope that helped out there. You just got to remember your little trig functions for finding your heights, remember? And so anytime you got a little right triangle, you can use sine, cosine, tangent. All right, take care, and good luck.